Oh, well, all the attendees. Oh, there we go. Hello. They're not ready. Our speakers today are not ready yet. Um, so just wait a few more minutes and I believe they should be ready to present to you all today. Thank you for your patience.
I think I'm gonna have to do it on my phone. Okay, Patrick, are we ready to start?
Yeah, I'm good.
Okay. Could you share your screen? Like I said, my laptop's
Okay.
having issues. Yeah.
Yeah, I can do that.
Okay.
Uh, okay,
Okay, so this
so
is okay, yeah.
so today we're going to be actually let me introduce myself. I'm Patrick and the other person is Johnny. We are members of team 25729 CIPHER, an FTC robotics team, and today we're going to be introducing to you some of the basics of Android Studio. And here's a table of contents of roughly what we're going to be going over today, and I'll just give it over to John.
Okay, so what is Android Studio, right? Android Studio is the official IDE, which is Integrated Development Environment by Google, and it's for Android applications such as FTC Robot Controller. It uses Java to program, so it's a lot better and more efficient than what most people use. So it's better than Blocks because Blocks is very limited by what they can do with libraries and other types of more advanced code blocks. And OnBotJava is also worse than Android Studio because of the lack of libraries such as OpenCV and like Java Array, Java Math.
Oh, so what we were planning to do is to install Android Studio on a virtual machine. However, the virtual machine is not working well with Zoom, so it appears that we will have to table that today. But regardless, we will still be explaining to you how to install Android Studio.
Okay, Patrick, I managed to get my laptop working. I can screen share.
Okay. Okay, so please hold on a minute. We are setting up the virtual machine and the Zoom on Johnny's laptop. He will be presenting from now on, and he'll be showing you how to present more specifically.
So the first step to setting up your Android Studio is getting Java. Okay. Java is the language and you're gonna need it for Android Studio itself. So to start, you're gonna go to the Java website. Oh, and you can follow along, but I'm pretty sure these are recorded, so if and I will send a link to the presentation in chat shortly. But to start, you install Java from the Java website. You're gonna select your operating system and then download
whichever installer you need, and then follow the setup wizard. Okay. And once you have Java installed, you want to go to this link here, developerandroids.com/studio, and download the latest version of Android Studio. And then follow all the instructions through the setup wizard. And now a very important part about Android Studio, and it's how you're going to connect to your robot once you have Android Studio and all your code set up, is to install SDK platform tools. Okay. Your first step is going to press the line, click on the 3 lines, which will bring up a menu like that looks like this. Then you press Tools and SDK Manager to pull up this menu. Once you find this menu, continue with SDK Tools and scroll down till you find Android SDK Platform Tools. To download, press OK, and then follow the rest of the installation. And once you install it, your Android Studio should look the same. But then you want to get the base FTC controlling code that you will use for controlling your entire robot. So to do that, you want to go to this GitHub link. Sorry, this GitHub link and click on the releases version 10.3, download the source code file, and get the file as a zip. Once you're done with that, you want to extract the file into a unzip version. And in Android Studio, click on the 3 lines, press open, and then it should import it into your Android Studio. Once it's imported, Gradle should start building. If it didn't, you most likely imported the wrong file. Because when you get it as a base file, they're split into 2. You want to open the first one and then take the unzipped file inside the first file. And once it's all built, it should look like this. So once you have your Android FTC robot controller set up, there's 3 main files that you should know, okay? The first file is FTC robot controller. This contains a lot of the libraries and samples that you use throughout your code. Then there's team code, which is the most important file. Team code has what your robot's going to run in this folder called org.firstinspire.ftc.team code. This is the most important folder in your code because this is where your code is going to live, the code you make. And then finally, there's Gradle scripts, which you don't need them too much, but for stuff like Roadrunner and like Pedro pathing, you might need to add some imports there, but that's all in its documentation. Usually, if you do need this, it will be in the documentation where you need it. So now, connecting to your controller, your control hub on your robot is very different from how you would from OnBotJava or blocks. The easiest way, and this is for Windows only, Mac, I'm a bit unsure. You could probably find documentation on that. I'm sorry if you're on Mac, but this part won't really help you. So you want to go to the app called Run, then open %local app data in the Run menu and find Android. This is Android Studio. In Android Studio, you want to find the SDK file and find platform tools in the SDK file. By right-clicking it, you can open it in your terminal, and then the terminal should look like this. This is your username, this is the path, and it should end with platform tools. If it doesn't, try right-clicking platform tools again. You might have just opened SDK as in your terminal. And then there's 2 commands that you should know. There's ADB connect 192.168.43.1555. This is a universal connection command for any robot or like any FTC robot specifically, but you won't need to change this. And then there's also ADB disconnect all to disconnect your robot from your laptop. This is very important because if you were to turn your robot off before you disconnect, nothing too bad would happen. It's just the next time you use that laptop to connect to the robot, you're gonna have to connect to the robot, disconnect, and then do a bunch of random steps to debug it out. And we have a sample teleop code. This code is pretty simple. It's just showing the basis on how to get your robot to drive, right? We can split our code into 5 sections. You have the libraries, the imports that get imported at the start, class declarations, your motors declarations, and then the actual motor gamepad inputs and motor movements. So for libraries, we have the most basic library is going to be package org.first.inspire.ftc.team code. This should be automatic. Once this is put in here, every other import like this import or teleop, every other FTC import will be imported automatically once you type out a function that uses them. And then extra libraries can be added on by using import something or whatever the library name is. For example, import java.util.ArrayList will import Java's ArrayList library. Then you have your class declarations. All classes for teleop are declared using what's that called? At teleop name, and then the name with the group of what group you want your teleop to be in. Then you want to say that it's a public class, and this class name should be the name of your Java file once you create it in team code. And then extending it to linear op mode makes it a teleop. Then you want to override the code and use public run op mode to start your program. This is what happens. Everything after this curly bracket is going to be what your program runs after the robot is initiated. Then using wait for start, you can differentiate initiation in the actual starting of the robot. And then using while op mode is active, it gives you not really forever loop, a loop during your teleop mode. And this basic format is essentially what you will use for every teleop. There's not many changes to this that you might need, except for like extra classes. Then you have your motor declarations. To declare a motor, you need to first define a DC motor with the variable name you want. So in this case, it's left front, left back, and right back, which are 4 motors. Then you want to assign each variable to an actual motor on your robot. And these two don't need to be the same name. This can be like X, Y, Z, and this can be this, but this box right here needs to be what's on your actual robot. And then after declaring your motors, if you want to see what your motors are, how they're moving and how long they're moving, you want to turn on the encoder. And to reset it, you use this command or this line of code. And then for most chassis, 2 of the motors need to be reversed for the robot to move straight. And to reverse it, you can use set direction DC motor direction reverse with your variable name. And every command should be done with your variable name, not the name of your motor, unless of course they're the same. Then there's motor movement and connecting it to your gamepad. Connecting it to your gamepad is super simple, right? Every team has 2 controllers, and it's either gamepad 1 or gamepad 2. The value box is whatever control you want to take from. In this case, we're using left_stick_Y, which is the left stick on the gamepad and the Y axis. You can have left stick X, you can have the right trigger, right bumper, whatever D-pads, whatever control you want. And then in our code, after we get the power, you can set the power using the motor name and then the power value. and power values reaches is -1 to 1, which we did here using math to max it out so it doesn't go over. And then a way to get feedback to debug specific code that you might want to debug is by using telemetry.addData. You can show text and then changing value. So for example, in our code, we wanted to see the position of the left front motor, and we did that by setting a name, which is left front position, and then using the function left front.getCurrentPosition to get the current position of the left front motor.
Okay, so I'm going to be talking about I'm going to be talking about vision, and vision is basically when you use a camera on your robot to see your surroundings and analyze information. So, for example, you can use autonomous. In autonomous, you can use vision, and you can for example, in last year in Into the Deep, the samples were randomized, so it's really helpful to use vision to see and pinpoint exactly where the samples were. And vision, this year specifically, vision, you can see that it's quite important because the artifacts are different colors, and a simple way to make your robot run is to just use vision and pinpoint the exact locations of the artifacts. And of course, there's April tags as well. You see the April tags on the place where you score, and you can use vision to determine April tags and shoot as well. Yeah, next slide.
Hey Patrick, could we switch who's sharing? Is that fine
Hmm?
with you?
Yeah,
Could you
that's fine.
Okay.
Yeah, I can share. Hold up. Here we are. Okay. So you have many vision applications in FTC. So one of the things that FTC SDK, the software development kit, used to support was TensorFlow, which was made by Google. However, it's deprecated. It's no longer in use because of unreliability issues. And April tags are the field navigation tags. They sort of look like QR codes, and they help in helping your robot know where to go and where to aim and such. And there is a new camera or vision system that is called Limelight. However, Limelight is quite expensive. I'm pretty sure that's $190 or so, whereas with OpenCV, which is what I'm going to talk about today, that only requires a cheap webcam. So what is OpenCV specifically? So last year, because we needed precise control for our drivers to grab samples, we had a vision program or OpenCV to determine where the samples are. Now the way OpenCV works, it has a pipeline, and it goes through the pipeline to determine what it wants. So you can have I have an example of a flowchart here. So we can see here that the camera and the lights are turned on. It has the image, and it's going to find all the blobs or all the contours of the yellow or lines color, which is the samples that we want. So it is going to then choose a contour at random and check if its size is correct. And if the size is correct, it is going to calculate the difference between the X and Y coordinates to see if that contour is the closest, and it's going to repeat this process until it finds the closest contour. Um, that's a little bit of an oversimplification, but that is how it works. Eventually, it finds the closest one, and it converts the pixels, this is the distance in pixels with the camera center, into inches, and then it moves the robot accordingly. And this is the example code. It looks quite overwhelming, and that is why I'm not going to go in depth, but this is because we're going to be sharing the presentation. This is something that you can use as a guideline. So of course, you can see we have the imports that we've covered. Usually when you code, Android Studio will automatically add imports, so that's nothing too much to worry about. This is at autonomous because this code specifically is in autonomous. You have the class, and you declare the webcam the same as you declare a motor or a servo, and you have variables which represent the X, Y position and the area. And then this is just setup, which I'm not going to go over too much. But here we have the pipeline to the right, on the right column. We're going to make a new pipeline. And of course, we're going to set up the webcam, identify the pixels. And here, this is an example of telemetry. In our pipeline, we're going to return CX, CY, and an area, which helps you see these telemetry data on the driver station. And this is the bulk of the code. This is the pipeline. And I'm going to skim over this pretty fast because again it's going to take a long time for me to explain this in depth. So this is a pipeline. It's a class OpenCV pipeline. And one important thing to know when you are doing OpenCV is not to use BGR or blue, green, red. So blue, green, red represents colors based on how much blue, green, or red they have. But the issue with this is that it does not account lighting. So if your robot is playing in a dark field compared to a field with a lot of lighting, you're going to get different results. So that is why you have to use HSV, which stands for hue, saturation, and I'm pretty sure that is value. But you need to convert BGR to HSV. And you're going to create a mask to isolate the yellow objects. And this is the color values that you want. The color values vary. I do not think that there's a I've tried to find online resources, however, I could not find like any resources to find me up for example, to find like a specific color of yellow. So your scalars or the ranges that you need to find, you're going to have to tune those yourself. I do not have a guarantee that these exact ranges will work, but regardless, here we are going to find the contours in that mask. So we're going to just list contours. We're going to create a list, and it is going to, and then it goes through, and it is going to have a variable. The variable is saying that this variable is the center of the image or the center of the camera. It is just the width divided by 2 and the height divided by 2. And on the right column, we can see that we are looping through all of our contours. So before we have any contours, we are going to find the area. Now, OpenCV also relies on functions. For example, in image process contour area. So it is important to know these functions. And again, you can view this presentation because we are sharing it. So we have the area, and we're saying that if the area is more than 5,000 pixels, if it is, for example, you could have like something, a piece of tape that's really small and insignificant. You don't want to notice that in your robot. We're going to find the x value, and again, this is another example of a function, m.m10 over m.m00, and we have double y. So we have the x position and the y position of the center of the contour. And we can find the distance from the image center using the Pythagorean theorem. So this is how the OpenCV loop works. So if the contour that we have is the closest to the center, that is our best contour. That is the contour that we want. And so it's going to loop through every single contour. And if it's not the best contour, if it's not better than the last contour, it's just going to throw it out. And eventually we should have the contour that is closest. So if we have set hasBlock, which is we have set the condition hasBlock to true if we have found the one with the closest distance. If hasBlock is true, so if we do have a sample, we are going to export this to telemetry, CXCYA. And if you go back here, our telemetry is exporting CXCY in area. So that's how it works. It says return input, so it goes back and it spits everything out for the telemetry. And this is a very, again, this is a very basic example of OpenCV. All it's doing is giving out the telemetry, and it's not really identifying anything for the robot to move specifically. But again, this is something that you should definitely base your code if you want to use OpenCV off of it. And this is an example of our robot using OpenCV. Oh. So it's going to, if I play it in loop, it's going to loop over and over again. It's going to look really weird. But you can see that over here, the robot is turning its lights on, and this OpenCV loop works really, really fast. All of this is happening in less than a second. So you can see that it's the light is turned on and sees the sample, right? And it's like, oh, there's a sample. And then very quickly, and then again, less than half a second, I would say, it determines that the sample is there. The sample's position is X and Y, and then it converts the positions to the motor powers and durations, and then lo and behold, the robot grabs the sample. So that's an example of OpenCV in action. So by this point, we are finished with our presentation, and a lot of our time is going to be used to answer Q&A because OpenCV and Android Studio, mostly Android Studio, can be a little bit difficult to grasp. But once you get the hang of it, it should be pretty intuitive. So we are now going to open up the Q&A section for any questions that you may have.
Also, Patrick, if you if you stop like presenting and then represent the slideshow, I think I added a QR code for the presentation.
Oh,
Oh, I can screen share. This is a QR code if anyone wants to use it. This is to the presentation, so if you need more help and or to look back if we went too quick, you can do so.
yeah. Okay, so we have our first question. Sophia has asked, for decode for this season, can a team be successful by just using April tags? And I can answer that. Mostly this year, I can say you can be successful using only April tags because the artifacts are prearranged in a specific order, and that order is not going to change. So as long as you know the order and you code your robot correctly, you shouldn't need to use OpenCV that you shouldn't really need to use OpenCV. And of course, April tags, you're using it to locate where you should launch. And I would say definitely you do not necessarily have to have OpenCV um to to have a successful season this year. But I would definitely recommend using the April tags to shoot your artifacts. And Jonathan, do you want to add more on that?
Yes, uh so since like I said in Android Studio, right, they give you a lot of free example code and free libraries that you can use. I think they have one for yes, they do. Okay. Let me screen share. So in a very helpful resource is that in Android Studio itself, when you install FTC Robot Controller, in FTC Robot Controller, the actual file, there's Java and then there's external samples and internal samples. Internal samples don't really matter, but external samples, you get like 30 free concepts. Like for April tagging, you can use this code and use like April tag processing and edit it to be your own. This is all very helpful as if you're just starting off with Android Studio or just starting off with Java, the coding language, because this is all this is pre-made code. So like if you need April tag help, you can use this. If you need an teleop help, you can use this. So all in all, this is a very great resource for you to use.
Yes, do we have any more questions in because we would welcome questions. Anything that you are concerned about or you are not confident about, you should definitely ask those questions right now. Um, so click the Q&A, answer anything that you have. Really? Really, no questions? All of you, all five of you have got it? Really? Well, that's nice. Um, well, it appears that um, can we can we end our presentation early? Is that a possibility?
Yeah, you can. I think it won't really conflict with the next meeting,
Yeah.
so you can go ahead if you are ready to end the meeting.
Yeah,
Any more
so
questions?
because we just want to make sure that none of you like has an extra question that's going to pop up and then we end the meeting and we won't answer it. Okay? So we do not have any questions. Well, thank you. Thank you for listening to our presentation and we hope that you have a
A
wonderful
great.
season. Yeah. Wonderful season using Android Studio and Vision. Yeah, thanks.
Okay, thank you. I think we can end it.